Hello everyone, in today's video, we'll go over the major elements from the two tutorial videos that were provided to us. Let us start with part 1, which covers the fundamentals of microarchitecture as explained by Boyd Phelps, Intel Corporate VP. In this section, he discussed what a CPU is, also known as the computer's brain, as well as its functions and applications. Moore's law was mentioned, as well as the ability to continue shrinking transistors. A comparison of the sizes of motherboards 40 years ago and microchips today was also shown. Boyd Phelps discussed the history of computer architecture, beginning with the ENIAC in 1946 and progressing through the engineering jargon VAG. How von Neumann simplified computer design and programming during his time, and how Robert Noyce founded Intel with Gordon Moore, forever changing the whole world. This chapter of the video discussed how the computational instruction layers are comprised of a hierarchical procedure that begins with the most basic things, such as atoms and transistors, and progresses to its final point, which is the actual application of the system. Instructional set architecture is referred to as the bridge between the hardware and the software by Phelps. ISA contains a large number of instructions that allow it to perform specific operations as desired by the user. This is referred to as operational codes, or opcodes in short. For the part 2, we discuss the key building blocks of microarchitecture. Let us begin. This section of the video discusses the implementation in the microarchitecture design, all the steps in processing the instruction, also known as the CPU pipeline, how it controlled by a clock, and introducing speculation, which is predicting branches with near perfect accuracy. Phelps-Boyd explains how local copies of main memory internal instructions, referred to as cache, are used to compensate for the long round-trip time to main memory. Micro-operations on how it acts as a connector between ISA and microarchitecture were explained. It was mentioned that the amount of ALU used has a significant impact on the microprocessor. To summarize what we've discussed, let's start with the fundamentals of CPU design, such as the von Neumann cycle, which includes fetch, decode, execute, and write back. Next, we've looked at how the depth of the pipeline is determined by the number of stages per basic function. Then, we've also learned how speculation is used to improve CPU performance. And finally, we now know that the CPU front end is where the CPU predicts what instructions are needed next, and the back end, where we learned how the decoded micro-operations are officially assigned to execution units using both superscalar and out-of-order execution. Since ENIAC's time, scientists had put in a lot of effort, and we'd gone through a lot of changes. We all know that technology is always evolving, and despite decades of invention, we are still not at the pinnacle of technical progress. We humans should be wise enough to use this as a gift, rather a means to our demise.